Yeah, 2 o'clock, yeah.
Tutorial questions. Okay. So yesterday we did question number 1 and the proof for the bit error rate when the channel H is fixed. Okay. So in the second question, I am reading the question first. So consider the Rayleigh fading channel H and verify probability of error is equal to expectation of Q in bracket square root of 2 mod of H square into SNR, which comes out to be half 1 minus square root SNR over 1 plus SNR. We have to prove this. Okay. So write this. So this is visible, right? So I am denoting SNR by gamma. Okay. So this is what we have derived yesterday. And now we have to take the expectation for H. Okay. So everybody know how to take the expectation, right? So we have to take the expectation with respect to H. So yesterday we proved H is what? Rayleigh. And H square is what? Exponentially distributed with parameter 1. Okay. So we can assume this as Q square root 2 x gamma into the PDF of x, which is exponentially distributed, that is e to the power minus x. What is the PDF of exponential distribution? If we have some variable exponentially distributed with parameter lambda, its PDF is given by lambda e to the power minus lambda x, where x is greater than or equal to 0. Okay. So lambda parameter here is 1. So we will have dx and its limits from 0 to infinity. Okay. Now we will expand this. We can write the expression for Q also. So let's say this is x and s equals to 0 to infinity and y equals to square root 2x gamma to infinity e to the power minus y square divided by 2 divided by the square root of 2 pi into e to the power minus x dx. This is okay, right? I have just substituted the value of Q function. Now, if we see here, x is going from 0 to infinity, okay, and y is going from some line to infinity, okay. So this is like a vertical strip. Okay. So where x is going from 0 to infinity and y goes from particular value to infinity. Okay. And this line is y equals to square root of 2x gamma. Okay. So what we want to do now, we want to change the order of integration. Okay. So instead of taking this y strip, we can take like this x strip. Okay. So this will change the limit of the integration. Okay. So what will we have? We will have, so this is x and this is y. So y will go from 0 to infinity. Y will go from 0 to infinity, and this x will go from 0 to up to this line, and x will go from 0 to this line, and this line is what? Y square equals to 2x gamma. So x is equals to y square divided by 2 gamma. So y square divided by 2 gamma. Okay. And we will have same thing, y square divided by 2 into e to the power minus x dx and dy also, dy divided by square root of 2 pi. Okay. Now this y square, we can solve this. Okay. So we will write here so we will have this limit. So we will write here y equals to 0 to infinity e to the power minus y square divided by 2 divided by square root of 2 pi into dy and 0 to y square divided by 2 gamma e to the power minus x dx. So this is x. Okay. So we can solve this. This comes out to be e to the power minus x divided by minus 1, and we can put the limit here, y square divided by 2 gamma. Okay. So this comes out to be 0 to infinity e to the power minus y square divided by 2 divided by square root of 2 pi, and this is if we put 0 minus e to the power minus y square divided by 2 gamma minus minus plus is 1. This is okay, right? I just substituted this value, I get this. Any problem up to this point? It's just simple derivation, okay? Now we can divide this into two parts, 0 to infinity e to the power minus y square divided by 2 square root of 2 pi dy minus please don't talk. So we have a 0 to infinity e to the power minus y square divided by 2 1 plus 1 over gamma divided by square root of 2 pi dy. Okay. Now if we solve this, this is what? This is just the normal distribution being integrated in the half. So we will have this value half. If we integrate from minus infinity to infinity, we will get 1, and we integrate from 0 to infinity, we will get half. Okay. And what about this? This also, let's assume this value to be, let's say 1 plus 1 over gamma is equals to 1 over sigma square, let's say. Okay. So what we'll have to do? We have to here multiply and divide by sigma square. Okay. So this value also will become half. So what we will get? This sigma will come above, sigma divided by 2. And what is this sigma value? Okay. This you get. So this integration will become like 0 to infinity e to the power minus y square divided by 2 sigma square divided by square root 2 pi sigma square dy, and this sigma will come here. Okay. So this is what? Just the PDF of Gaussian we integrated from 0 to infinity. So its value will be half. So we will get sigma divided by 2, and the value of sigma is like this. So what we will get finally? 1 by 2, 1 minus square root gamma divided by 1 plus gamma. Okay. This is the same thing that we have to prove. Okay. Any doubt here? Now this value we can write for high SNR. So I can write here 1 by 2, 1 minus 1 plus 1 by gamma to the power minus 1 by 2. I am writing the value as same it is. Okay. Now I can put the since gamma is high, this value is very, very low. So I can put the high SNR, the approximation for this 1 by 2, 1 minus 1 minus 1 by 2 into 1 by gamma. Okay. So which comes out to be what? 1 over 4 gamma. Okay. So this is the high SNR approximation. Okay. So the next question, any question here? Yeah. Y equals to from this value to this? This one. So this limit represent the, we take the strip, the horizontal strip. It represents the horizontal strip. So I change the limit of integration. So I took the vertical strip for integration. I mean it's vice versa, sorry actually. So this represents the vertical strip and I took the horizontal strip. Okay. So in horizontal strip it goes from 0 to infinity, this value of y, and the value of x goes from 0 up to this point, and this line is y equals to square root 2x gamma, and we solve for the value of x, I will get y square divided by 2 gamma. Okay. So it's just a changing the order of integration. No, these terms will not be affected. We are just changing the order of integration. This term will not be affected. So this is the similar thing that is taught in the mathematics first year courses. If you just go and you will find out, like this is the same thing, nothing fancy here. If you want, I can tell you more about it. Okay. So the third question is a precise way of saying that the probability of error PE decays like 1 by SNR with increasing SNR is the following. Limit, let me clean this. The third question. So limit probability of error into SNR, or when SNR tends to infinity is equal to C. So where C is the constant, identify the value of C for the Rayleigh fading channel. Okay. So here we are getting 1 by 4 gamma. Okay. So if we put like this, limit gamma tends to infinity, our probability of error is 1 by 4 gamma, and SNR is gamma, which is comes out to be 1 by 4, which is the value of C. Okay. Okay, any question here? Okay, now let's move to the question number 4. You are, or everybody has questions, right? So you can look at them. Okay. Question number 4. Now we want to test how robust the above result is with respect to the fading distribution. So let H be the channel gain and mod of H square be an arbitrary continuous PDF Fx, satisfying Fx F0 is greater than 0. Does this give enough information to compute the high SNR error probability like in previous part? Okay, so earlier we assumed this to be exponential distribution, right, mod of H square. Now this question is saying we do not know about the distribution of mod of H square. What we will do? Does we still get the same answer or not? So for that, let's just compute this, because we have to finally see this product, gamma into PE. So which is equal to gamma expectation Q value. Let me clear this. Square root of 2 mod of H square into gamma okay, so which comes out to be, so we have Q square root 2 x gamma, and the PDF of this I don't know, so I will write here Fx dx. Okay. Now what can I do here? I can do the change of variable. Let t equals to 2x gamma. Okay. So dt is equal to 2 gamma into dx. So what will I get here? So gamma is here. So factor of 2 will come. So gamma dx equals to dt by 2. So 1 by 2 q t f x, instead of x I have to put t divided by 2 gamma into dt. This is okay, right? Now we have to do this limit. If we have to find out our probability of error decreases by 1 by SNR, this is the way to check it. Okay. So if we have to check this probability of error, if we don't know the probability distribution of mod of H square, is this still decreasing by 1 by SNR? What we have to do, we have to compute this product and take the limit, and if we find out whether this is constant or not constant. Okay. So if we put now limit gamma tends to infinity, what we will get? Let me write here limit gamma tends to infinity, gamma into PE is equal to what? We have 1 by 2, and so gamma tends to infinity, this will go to 0. So F0 will come outside, and we have QT dt, and the limit here will be, so this H square is a positive quantity, so limit here will be 0 to infinity. Here we have made change of variable, the limit still remains from 0 to infinity. Yeah, yes, square root will be there. Denominator of 2. So T equals to 2x gamma. 1 by 2 is still there. Okay. So 1 by 2 is still there. So what I'm saying here, the limit will be 0 to infinity, and we have square root of t here. Okay. So f naught is coming outside. So this value will be, so we are integrating like 0 to infinity this q function. So its value will be approximately equal to half. Okay. So we can write f naught divided by 4. Okay. So we get this constant. This is constant. So if it is coming constant, then we can say our probability of error is decreasing by 1 by SNR, even if the fading, this fading distribution is some different than exponential distribution. Okay. Okay, clear? Any question here? Okay, we move to the next question then. Next question says, consider the Rayleigh fading channel and show the following. Question number 5. Show the following probability mod of h square into SNR, let's say SNR is gamma, is less than equals to 1. We have to calculate its value. Okay. So mod of h square is exponentially distributed, right? So this value we can write like mod of h square less than 1 by gamma. And this exponential distribution, it means this value is positive. So 0 to 1 by gamma we have to go, right? An exponential distribution is lambda e to the power minus lambda x. So e to the power minus x dx. Now I put this value e to the power minus x divided by minus 1 by gamma 0, which comes out to be e to the power minus 1 by gamma minus plus 1. Okay. Now this is saying it should be 1 by SNR plus O 1 by SNR square. Okay. So we can just expand. So 1 minus, we can expand this 1 minus 1 by gamma plus 1 by gamma square 2 factorial plus and so on. Okay. So we expanded this exponential into a series. So what we will get 1 over gamma plus some term based on 1 by gamma square. Okay. So this is the solution for the 5th question. Now let's come to the 6th question. Consider an L repetition code with Rayleigh fading channel and BPSK modulation. So L repetition code. So let's say y equals to hx plus w. So where we have L repetition code, the error probability condition on h can be written as like this. Okay? So this expression you can obtain similarly that we obtained for the BPSK. Okay? So do you want me to derive this expression that is written here, or you can get the expression? Should I derive it? Okay. So we have the repetition coding. So this is L cross 1, this is L cross 1, and this is L cross 1. Okay. So the same thing is being sent L times. Okay. So that's why it is repetition coding. Okay. Now let's say BPSK modulation. So x will be plus minus square root of p. Okay. So we can write probability of error condition on h. So h is fixed at the moment. Okay. After we derive with h fixed, the expectation on h. Okay. So which will be equal to the probability of error. It means we have to multiply with h Hermitian y divided by norm of h, and x is BPSK, so we have to take the real part, and this should be greater than 0 if we are transmitting x equals to minus square root of p. So this is the probability of error when we are transmitting x equals to minus square root of p, and we are favoring the positive part. This thing is okay? Any question here? Okay. So this thing is so we can write this real of h Hermitian y greater than 0, x is equals to minus square root of p, and we can put the value of y. So real of h Hermitian h into x is equals to square root of minus of square root of p plus h Hermitian w greater than 0. Okay. So that comes out to be probability. So this is h Hermitian h is real, and this is also real, so we can take it outside. So h Hermitian h into minus square root of p plus real of h Hermitian w greater than 0. Okay. So this, what is the statistics for this one? Okay, we have to find out the statistics. So real of h Hermitian w. So its mean will be 0, since the mean of noise is Gaussian with 0 mean and variance. So let's say w is Cn 0 comma sigma square I. So it means w has 0 mean and sigma square variance, and its entries are uncorrelated. Okay. Identity means its entries are uncorrelated. Between the entries there is no correlation. Okay. Now we have to find out this. So let's find this another way. H Hermitian w plus w Hermitian h divided by 2, and we have to take the expectation. So we have to find out the variance. So variance of real of h Hermitian w is equal to expectation of, so real of h Hermitian w So its mean is 0. So it will be just the square. Okay. So expectation. So if we just put that value, so we can find out the way that the way we did yesterday. We can also find it this way. Okay. Both are okay. Both will give the same answer. So H Hermitian W plus W Hermitian H. So this is square divided by 4. So what will I get here? Expectation. So it will be long one. Square 2. So H Hermitian W square plus W Hermitian H square plus 2 W Hermitian H square divided by 4. So 1, 2, 3, 4, which is equal to expectation of H Hermitian W square, which is equal to expectation of H Hermitian W Hermitian H, which is equal to H Hermitian expectation W Hermitian H, which is equal to sigma square I H Hermitian, which is equal to H Hermitian H into sigma square. Okay. If we do the square here, I will get one term, and twice into this term, 2 plus 1 plus 3, 4. Yeah, that's it. Okay. So this is just one way. You can derive also, like assuming real part and imaginary part. You can do by that way also. Okay. Both will give the same answer. Okay. So now let's come to this here. So real part of this, H Hermitian W greater than H Hermitian H square root of P, and this value is n 0 comma H Hermitian H sigma square greater than H Hermitian H square root of P, which is equal to probability. We can take it outside, norm of H into sigma n 0 comma 1 greater than H Hermitian H. We can write it mod of norm of square root of P, which is equal to probability n 0 1 greater than norm of H square root of P divided by sigma square. Okay. Is okay. Now we will have this as Q value H square P divided by sigma square root this. Okay. So this is the same thing we are getting. We miss somewhere factor of 2. Okay. The same thing we are getting, but factor of 2 we have missed somewhere. Okay, so there will be a factor of 2 we have missed somewhere. Okay, I will come back to it. So now with given this H, we have to take the expectation of q square root 2 norm of h square into gamma. I am calling gamma as the SNR. This is the probability of error. And we have to calculate this. So one thing, we earlier note that mod of h square is exponentially distributed. Now if we have multiple random variables, that's the summation of it, that distribution is chi square. Okay? So the chi square has two parameters. One is the variance and second is the degree of freedom. The degree of freedom depends of how many parameters are added here. Since h is, so if let's say, if we have some xi complex random variable, let's say n01, okay, and let's say I equals to 1 to n, okay. So mod of xi square, summation of it will be chi square distributed with how many degree of freedom? N degree of freedom, okay, and with the variance 1, okay. Now here h is complex and we have how many elements here? L elements here. So total how many elements? 2L elements are here, okay. Is this you are understanding, okay, right? So we have chi square distribution, h square is equal to summation I mod of hi square will be chi square distribution with 2L degree of freedom, okay, and its variance will be what? Half the variance of each of the entries. So if h is distributed Cn01, okay, then its real part and imaginary part both are counted as separate, okay. So it will be 1 by 2 and 1 by 2, okay. So now we can write this expectation as x equals to 0 to infinity q square root of 2 x gamma into x to the power L minus 1 e to the power minus x divided by L minus 1 factorial into dx, okay. So this is what? This is the PDF of chi square distribution. This is the PDF of chi square distribution, okay. Now we do the similar procedure. We have the integration for x. We write the integration for this square root of 2 x gamma to infinity and e to the power minus y square divided by 2 y square divided by 2 divided by square root of 2 pi into dy, and this thing x to the power L minus 1 e to the power minus x dx divided by L minus 1 factorial, okay. Now with these two integration, we will do the same thing that we did earlier, changing the order of integration, okay. here, so we have this line and x is going from 0 to infinity, so it is vertical strip, and y is going from 2 to infinity, so we have to take horizontal strip. So this is the new strip. So this comes out to be y equals to 0 to y equals to 0 to infinity, and x is equals to 0 to up to this line, that is y square divided by 2 gamma, and I write the same thing here. This is for x, so let's write for x term first. So x to the power L minus 1 e to the power minus x divided by L minus 1 factorial dx, then e to the power minus y square divided by 2 divided by square root of 2 pi into dy. So this integration, we can solve it. Okay. So how we will solve it? By integration by parts. Okay. So y equals to 0 to infinity so let me give you an example of integration by parts, then I will write the direct answer for this. Okay. So if we have some x square e to the power minus x dx, so how will we solve it? So if we solve this, we will have 3 terms. Okay. So first we will have x square e to the power minus x dx, first part, and second integration of second part, minus integration of first part, then differentiation of this, that is 2x, and integration of that, right? Then for this also I can divide this into 2 parts. Okay. So I will have 2x, then integration of this part, so e to the power minus x, it will remain the same, it minus will come, so plus will come here. Then minus, we will have 2 here, into differentiation of 2x is 1, then we have e to the power minus x integration of this, so it will become plus dx. Okay. So one term we will have for x square, one term we will have for x, and one term we will have for e to the power minus x. Okay. So this way 3 term will come. Okay. So whatever the power we will have x, we will have the integration that many times, plus 1. Okay. So that way we can solve this. So if I solve this, I will get this. Okay. So each time I will get x to the power decreasing. Okay. So that x to the power is coming here. I have put the limit from y square divided by 2 gamma. So that limit is coming here, e to the power x, and this factorial is coming, since it will be this integration will be done many times. So this factor will come here. Okay. You can try yourself also. Okay. So then we will get e to the power minus y square divided by 2 square root of 2 pi dy. Okay. So this is a standard integral, the solution of this. Okay. Now, so the first integration, second integration, we will do separate. So e to the power minus y square divided by 2 divided by square root of 2 pi 0 to infinity dy minus summation L 1 y L factorial and we have integration y equals to 0 to infinity, and we have 2 gamma to the power L y to the power 2L into e to the power minus y square divided by 2, 1 plus 1 by gamma divided by square root of 2 pi into dy. So summation is here, e to the power, this term are here, y square 2L here, and 2 gamma to the power L here, L factorial here, square root of 2 pi here, dy is here. Okay. So this term is what? This term is the expectation of this when y is Gaussian. Okay. So this is the 2Lth moment of Gaussian random variable. So 2L means this is even. So this is the even movement of a Gaussian random variable which has this much of variance and 0 mean. Okay. This term, okay, 2Lth moment of n0 comma this. So let's say this is let's say sigma square. So this I can assume 1 by sigma square is equal to 1 over gamma plus 1. Okay. So I can multiply here sigma square here, sigma square here. Okay. So sigma will come here. This part is 1 by 2. So I will write here 1 by 2 minus summation L. I have 1 over L factorial 2 gamma to the power L, and this moment. So moment you can check online, or you know the moment generating function. The moment generating function of a Gaussian distribution is like this: e to the power mu t plus sigma square t square divided by 2. Okay. So this is a moment generating function. You have to differentiate it if you want to get the 2Lth moment. So you have to differentiate 2L times. You will get that much moment for Gaussian distribution. Okay. So since mu is what? Mean. Mean here is 0. So what will you get if you have, let's say I am calculating the pth moment. For pth moment. For pth moment, if p is equals to odd, I will get the moment is equals to 0. If p equals to even, I will get the moment sigma to the power p into p factorial divided by 2 to the power p by 2 into p by 2 factorial. Okay. So here we are multiplied with 2. So this is even. So we will get this value. So this value we will put here. Okay. So we will have sigma here. I will write here sigma, and this value sigma to the power p, sigma to the power 2L into 2L factorial divided by 2 to the power L into p is equals to 2L, so L factorial. Okay. So I will get this expression. And of course this 1 by divided by 2, because this is 0 to infinity. Okay. So I can write 1 by 2, 1 minus summation over L. So I have 2L, L, L. So I can write in terms of combination. So 2L, L, and this This is taken care of. Then I have sigma to the power 2L plus 1. Then I have 1 by 2 is outside, 2 to the power 2L sigma to the power. Sigma is what? Sigma is equals to gamma over 1 plus gamma, okay, square root of it, right. So this term is taken care of, this term is taken care of, and gamma to the power L, gamma to the power L. This term I have merged with it, this term taken care of, this one, okay. So I have gamma over 1 plus gamma to the power 2L plus 1, 2L plus 1, and I have gamma to the power L here. So I can write this as so this is the answer if we want to get in terms of SNR. But if you see the question, it is calculated in terms of mu. Mu is equals to SNR over 1 plus SNR, the same thing as sigma. Okay. So if I write this in terms of mu, I will get something different, that is equal to so I will get mu times 1 minus let me do it from scratch 12. So what will I get there? I will get mu here, then 12 mu to the power 2L. So here we can calculate the gamma. So mu square is equals to gamma divided by 1 plus gamma, and 1 by mu square is equals to 1 plus 1 by gamma, and 1 by gamma is equals to 1 minus 1 by mu square. Okay. So we have gamma here. So I can write here 12 plus 1 here, and this gamma 1 by gamma I can write 1 minus 1 by mu square to the power L. So it is just the rearrangement of different terms to get the answer. So we have mu is equal to 2L, so we will take this, and so mu 2L plus 1 divided by mu to the power L here, and 1 minus, so we have 2 to the power 2L to the power 2L, 1 minus mu square minus 1 to the power L. Okay. So this mu L will be cancelled out. I will get I will get 1 by 2, 1 minus summation L 2l l mu to the power mu to the power l plus 1 divide and 1 plus mu to the power l divided by 2 1 minus mu to the power 2 divided by l. Okay. So this is the answer we will get. Okay. So should I explain it again or this derivation or summarize it again? So we started from this expectation of q, that random variable, okay, that has the chi-square distribution. So chi-square distribution we write it. After that what we did the change of limit, we change the limit, change the order of integration, and then we solved it, okay. In between we get this x into exponential term, integration of that, so we solved it, so it comes in terms of summation, okay, and after the summation we just rearrange the terms to get the answer, okay. So here we just note that our limit is going from 0 to infinity. Since it is going 0 to infinity, the half term will come here, okay. So here, since this term is here, it gives rise to the moment. So for the moment, we use the moment generating function. So moment generating function, we note that for even moments, it is 0 when mu is 0, okay. For when mu is 0, when p equals to odd, it is 0, okay. When p is equal to even, we are given, we will have this value, okay. So this value we have substituted here, and we get this expression, and I did only rearrangement of the term. So I find out the answer in terms of this value that I get from this when I was substituting here, okay. Now this question says we can calculate in terms of mu, that is square root of SNR over 1 plus SNR. So I did square root of 1 plus SNR like this, and every gamma I have to substitute in terms of mu. So I calculate the gamma in terms of mu, and I substituted that value here, okay. So here 1 by gamma is coming here. So 1 by gamma I calculated it to be 1 minus 1 by mu square. So I substituted here, okay. So then I rearrange the term. So I will get mu square minus 1 here to the power L, and this term I will get like this, and mu to the power L. So 2L will come here. So it will be 2L. So since this is mu square will go here, mu square minus 1. So 2L will cancel out. I will get only mu here. So mu here only, mu to the power 1, okay. And we have 2 to the power 2L, that is coming from all of the above from here, 1 to the power L here, 1 to the power L here, okay. So mu square minus 1, I can write it as 1 plus mu and 1 minus mu. So mu minus 1 will come here, mu minus 1 and mu plus 1, okay. And so this 2 I have distributed in terms of two values here, 1 to the power L here, 1 to the power L here, and this mu term remain here, and this is the expression, okay. So this gives the same value as this expression here, okay. Now it also says something about approximation, okay. So let's derive some approximation. Is this okay? So here, if you want to do this derivation by your own, you need to know what is the Gaussian movement. You need to know the about the Q functions thoroughly, okay, and the chi-square distribution. Okay, rest of it is simple calculus and rearrangement of terms. Okay. Let's clean this thing. So probability of error, we have to approximate by 2L minus 1 L 1 by 4 gamma to the power L, and at high SNR we have to calculate the deep fade. Okay. So let's take the expression that is given here, that is P is equal to 1 minus mu divided by 2 summation L equals to 0 to L minus 1 L minus 1 plus L 1 plus mu divided by 2 to the power L. Okay. So here, if we want to find out this, we have to do the similar thing that we did earlier. P into SNR, it should. So mainly we have to find out for the high SNR. So let's approximate 1 plus mu divided by 2, which is equal to 1 by 2, 1 plus 1 by gamma to the power minus 1 by 2, okay, which comes out to be, so this goes approximately infinity. So for high SNR I am writing, so 1 by 2 and so this goes 1 plus mu is 1 plus gamma by 2. Gamma is infinity, so 1 plus 1, which is equals to 1, okay, when gamma tends to infinity, okay, and 1 minus mu divided by 2 is equal to 1 by 2, 1 minus 1 plus 1 by gamma to the power minus 1 by 2 is equal to 1 by 2, 1 minus 1 by 2 gamma, which is approximately equal to 1 by 4 gamma. So with this I can write this 1 minus mu divided by 2 is equal to 1 by 4. So 1 by 4 gamma to the power L summation L minus 1 plus L, and this thing is 1, so it is 1 here. So this value comes out to be 2L minus 1 L into 1 by 4 gamma to the power L. Okay. So this approximation is clear, right? So I just pushed gamma tends to infinity, so this becomes 0, so this becomes 1, 1 plus 1 is 2, 2 into 2 is 1. And for high SNR, this term is very low, so I put here, so 1 minus 1 plus nx approximation I put here. So 1 minus 1 by 2 gamma, 1 1 cancel out, I will get 4 gamma. So I put these two values here, I will get this, and this term is a constant which comes out to be this, I will get this here. So what this term shows is that this probability of error is decreasing with SNR to the power L. So this L is the diversity factor, diversity order, okay? So next we have to calculate this deep fade. So probability of deep fade So I have to use the similar chi-square approximation, chi-square distribution here. So e to the power minus x into s to the power l minus 1 divided by l minus 1 factorial into dx. Okay. So what will I get here? So if so x is when x is very small, what we can do, we can neglect this term e to the power minus x, and I can write here like directly like this. So what I am doing here, this is the approximation. This thing you can also calculate in terms of summation. So like we did the earlier, you can also calculate this in terms of summation. But this value is very small. Since if we are talking about high SNR, then gamma is very high. Okay? So this value is very high and this is 0. So this value will be very small. Okay? So we can calculate just for the rest of the term. Okay? So that comes out to be x to the power l divided by l into l minus 1 factorial, which is 1 by gamma and 0. So which is 1 by gamma to the power l into l factorial. So this also shows that there is a diversity factor of l. Okay. So after that derivation, in these two approximation, there is no problem, right? Approximation are easy. Okay. So let's move to the next question. So this is the high SNR approximation. You can also derive in terms of summation, integrating by parts, L minus 1 times, you will get the same answer. Okay. So this is just to get the insight quickly. So in the next question, question number 7, we have to show the value of the Q function is bounded by the bounds of the Q values we have to prove. Okay. So let's prove one bound. So before that, let's say A is between 1 to infinity. 1 to infinity. Okay. So 1 by A will be between 0 to 1. Right? So 1 by A will be less than 1 and 1 by A will be less than 0. So 1 minus 1 by A to the power 4 will be greater than 0 and less than 1. Okay. If I take the A to the power 4, it will still be less than 1, and if I take here, so this will be greater than 0, and if I take 1 minus, so it should be greater than 0 here. Okay. This is okay. We will use this to solve. So for example, QA is given by A to infinity e to the power minus t square divided by 2 divided by square root of 2 pi dt. Okay. So here we have, let's say 1. So this 1 is greater than 1 minus a to the power 4. So I will put here 1 minus a to the power 4 here, e to the power minus t square divided by 2 is square root of 2 pi dt. So I can make this into two parts, 1 minus 1 by a square, 1 plus 1 by a square e to the power minus t square divided by 2 divided by square root of 2 pi dt. Okay. So limit here t equals to a to infinity. So t is greater than equals to a. It means 1 by t is less than 1 by a. Okay. So 1 plus 1 by t square will be less than 1 plus 1 by a square. Okay. So 1 plus 1 by a square is greater than 1 minus 1 by a square, 1 plus 1 by t square e to the power minus t square divided by 2 divided by square root of 2 pi into dt. Okay. So this term